All right, these are the notes for vertical linear transformations. So the first thing we're going to start with is our linear parent function, which is y equals x. So when we graph y equals x, our slope is 1. Both our x and y intercept are 0, 0. In the table for y equals x, when x is negative 1, f of x is negative 1. When x is 0, f of x is 0. When x is 1, f of x is 1. And when x is 2, f of x is 2. As a graph, it looks just like this. So when it comes to vertical transformations, we're focused on this part, this a value, and then this value, which is called the d value. This is going to cause this to shift up and down. And then this is going to cause a vertical compression. So think smushing it or stretch. So pulling it vertically. In a vertical translation, what's going to happen is we're going to take our function, f of x, and we are either going to add something to it or subtract something to it. So if we graph these examples, f of x equals x, then you graph g of x equals f of x plus 3. What this is going to do is our d value is positive 3. And so it's going to translate or shift the graph up 3 units to make this new graph right here, this g of x right here. And the new y-intercept becomes 0, 3. If we do the exact same thing, but instead of adding 3, we're going to subtract 3. So our d value is negative 3. This is going to translate or shift the graph down by 3 units. So it's going to create this function right here. And our new y-intercept, 0, negative 3. Which this makes sense because this acts like our b value in y equals mx plus b. We are shifting that y-intercept up and down when we are changing that value. In vertical stretches and compressions, so what we're going to do is we're going to take our function, f of x, and we're going to multiply it by a value. I'm going to call that value a. So, for example, we start with this example and graph this, f of x equals x. Then we're going to go ahead and create an a value of 2. So because this is an a value of 2, this actually affects our slope. So y equals mx plus b. This is going to affect our slope value. Our slope here is 2. So what's causing this, or what's happening here, is we're taking these points and we're stretching them up. So this is doubling this distance. And we're also stretching this down. So when we multiply by a value, an a value that is greater than 1, it causes a vertical stretch by a factor of, in this case, 2, which makes the graph steeper. Because again, it's affecting our slope, it's changing our slope. However, if instead of multiplying by a value that's larger than 1, we're going to multiply by a decimal, a value that is in between 0 and 1. So here we're going to make it 1/2. This is going to affect our slope, and our new slope is going to be 1/2. So instead of the point like this one right here going from -1 to 1, instead it's going to be held back. Instead of this point being way down here, -4, 4, -4, -4, it's going to be held back, and it's going to be compressed and pushed together. So this is a vertical compression by a factor of 1/2. And it makes the graph less steep. The one other thing that we can change is a reflection. And so what's happening here is we still have this a of f of x value, but instead we're going to make this a -1. So what happens when we have a negative, it causes our slope, again, this is affecting the slope. So instead of a positive value, now it's going to be a negative value. It's going to be -1. And it's going to cause a reflection. And if you look, you can't really tell if this is reflecting over the x-axis or if it's reflecting over the y-axis. Because this is happening with a vertical, this is actually reflecting over the x-axis. So what happens is, instead of this point right here, this original point was at 3, 3, it's now going to be reflected down here and be 3, -3. And this one, instead of -2, +2, or -2, -2, it's now going to be reflected up here and be -2, +2. So it causes a vertical reflection, so it reflects over the x-axis. And so those are all the transformations for vertical linear transformations.